everyone. The line L1 has a given equation and is shown on the diagram. Point A has coordinates 1, 4, and we want to show that A lies on line 1. So this is the first part of an IP question that was on an old test. So let's get started. So point A has coordinates 1, 4. So we go 1, 2, 3, 4. And it lies on line 1. So if I go up here, this would be 1, this would be 4. All right. So in order to show that it lies on there, you take the point and it should satisfy that equation. So for A, you would take 2 times 4 minus 1 minus 7. Does that equal 0? So you get 8 minus 8 equals 0. 0 equals 0. So yes. And then when you say it, so you on the IB exam, you'll say, so it lies on line 1. Okay? The point C has coordinates 5, 12. So this would be 5. And we're not sure where the 12 is. This is 4 here. 12 is probably up here somewhere. So let's check 5. Let's plug in 5 into this equation and see what happens. You get 2y minus 5 minus 7 equals 0. So 2y equals 12. So y would be 6. So that means that 6 is below the equation, or this line here. So let's just put it up here. Let's make it, we're just estimating here. So this would be 512, and this is point C. All right. M is the midpoint of AC. So 1, 4... 1, 4 is right here, and we're calling this A, and the 6 again would be lower. Let me put 4 down here. That looks funny. So that's 4. So here is your line here. Okay, this is 5. This is 1. All right. Find the coordinates of M. So basically we have 2 points. We have point A, which is 1, 4, and point C, which is 5, 12. And to do the midpoint, you just add these up, add your x's, divide by 12, 2, add your y's, and divide by 2. You're just taking the average. So this would be 3, 8. So the midpoint here is M, and this would be your point 3, 8. So this would be 8 here. You have a 3 here. Okay? Find the length of AC. So for AC, we're going to do the distance formula. So we have A and C. So that distance, use the distance of AC. That's going to give you, and you subtract your x's, square, subtract your y's, and square. So this is going to be square root of 4 squared, which is 16, plus the square root of negative 8 squared, which is 64. So this is going to equal square root of 80. And square root of 80, wrote it down somewhere, is 8.94 to significant figures. Exact value, significant figures. So now we have this length as square root of 80. Okay. Now, the straight line L2 the straight line L2 is perpendicular to AC. Okay, and passes through M. So some line here, perpendicular to AC, and it goes through point M. All right. Show that the equation L2 is 2y plus x minus 19. So the first thing I want to do is find the slope of AC. And the slope of AC is going to be, 12 minus 4 divided by 5 minus 1. So this is 8 divided by 4, which equals 2. So that's the slope of AC. So the perpendicular line 2 to AC has a negative reciprocal. So if I have the negative reciprocal of 2 equals negative 1/2. So I need to kind of put this back on. So this is 1, 4. And then we had 5, 12 is up here. AC. All right. So, and this is our midpoint. So for our midpoint line, that was 3, 8. To find the equation, and remember on your slopes, to show that slope of a line is perpendicular to another line, you have to show that the two slopes, when you multiply the two lines, it gives you negative 1. That's what it means by negative reciprocal. So we want to write the line, and let's write it as y minus, now this is the perpendicular line, so this is the point we're using, minus 8 equals our new slope, negative 1/2 x minus 3. Now we want to write it in this form, so let's go ahead and multiply everything through both sides by 2. So it's going to be 2y minus 16. These two cancels, so you're just going to get equals negative x and plus 3. We want to make it look like that, so move everything over. I'm going to add x to both sides. You get x plus 2y minus 16 minus 3, 2y. So that equals 0. And simplifying further, you get x plus 2y minus 19 equals 0. And so we put 2y. They're making the 2y go first, so just rearrange that 2y. Usually you put the x first. All right, so now we showed that it worked. And now we have a few more questions to answer. It said point D is the intersection of line 1 and line 2. Find the coordinates of D. So basically we had A, C, M, and then there's your perpendicular line. So this is line 2 going through this line here. And we're supposed to find the intersection. Well, basically, all you have to do is write down the two lines. So we know line 1 equals 2y minus x minus 7 equals 0. And line 2 equals 2y plus x minus 19 equals 0. You can do it in the calculator, or we can just do this algebraically by adding these two. So you add it, you get 4y. The reason it's easy to add, it eliminates the x. This is called the process of elimination. So 4y minus 26 equals 0. So y equals, move the 26 over and divide by 4. So we're trying to find that intersection. So y is 26 divided by 4. Now you have to find your x. So to find your x, you just plug it back into one of the equations. So we get 2 times 26 divided by 4 minus x minus 7 equals 0. So that goes into this 2 times. So you get 13 minus x minus 7 equals 0. Add 8 to both sides of the equation, and you get 6 equals x, because 13 minus 7 is 6. So that's your answer there. Or you can use a matrix or another thing. It says find the length. They say the length of MD. So this is D and this is M. MD is square root of 45 divided by 2. And it says find the correct length of 5 significant figures. So when you put that in the calculator, you're going to get 3.3540101 ... So 5 significant figures you count. 1, 2, 3, 4, 5. Draw the line. We can't, this rounds down because it's not greater than 5. So this is your 5 significant figures. All right. Now the last one is for G. I'm going to, oops, sorry about that. I'm going to draw this again. The point B is such that A, B, C, D is a rhombus. So we already have our A here. Our D, our B, let's put B here. Our C, we already did earlier. That was 512. And D is that line where it cuts through the midpoint here. So there was a midpoint here, and it cuts through this. So this would be D. So when you draw your rhombus, it looks something like this. And don't forget we drew the line. And that's just a sketch. So basically, we have 2 triangles. You have this triangle, and this is ABC. And that triangle is going to equal this triangle. So basically, to get the area of the rhombus, we can just do the area of triangle ABC. So that's 1/2 base times height. So our base of this triangle is going to be AC. And our height is going to be BM, because this point was M. So that's your height times BM, which we already calculated that. That's why we're doing the top part of this triangle. So that's going to equal 1/2 AC. We already did that part. That was a square root of 80, or 8.94. And BM was given to us, or MD. If that's MD, then BM is also square root of 45 divided by 2. So we're going to write 40 square root of 45 divided by 2, and that's going to equal 15. But now you're going to have to multiply that by 2, because we only took the area of half of this rhombus. So 2 times 15 equals 30. And that's it. Thank you. Have a nice day. Bye-bye.